To be helping you work through some Desmos basics today. So hopefully you have the handout that says using Desmos in the mathematics classroom. And we're just going to kind of work through some of those ideas. So the first thing we're going to do is we go to desmos.com and we hit the button that says start graphing. So this is going to take us to the standard graphing screen, which Desmos is most known for. And so you can input equations in any way that you want. So like a graphing calculator, you could put like y equals, and you could have something like x squared plus 6 or minus 7. You could do transformations where maybe you have a vertical stretch by 2, or you move things all to the right by 3. So there's lots of different ways that students can experiment with transformations and so on using Desmos. You can also record your screen like I'm doing now. I'm using QuickTime, and all I did is at the bottom of my screen, I did new screen recording, and I'm just recording it very easily with QuickTime. But there are lots of other apps that allow you to do that, like Screencastify, Screencast-O-Matic, and then I think on Windows machines you can just do Alt, Win, and R and hold all those down at the same time. So that allows you to explain the graphs much as I'm doing with you right now. So we're not just stuck with doing functions. We don't have to have a y equals. It will assume y equals without it. But we can actually graph things that are not functions as well. So if you remember when you used your graphing calculator, you always had to solve for y in order to put something in. So if I wanted a circle centered at 0, 0, I couldn't just put in x squared plus y squared equals 25 into a graphing calculator. I would have had to put it in as two separate functions, right, passing the vertical line test, with 25 minus x squared under a square root, and then also negative square root. So notice how I'm doing SQRT to get a square root. 25 minus x squared, and I do raised to x, or raised to the 2. So the raised to is by shift and 6. And in that way, I can see that I have my blue function, which is the top semicircle, and my bottom function, which is the green one. And together they make that circle that I had originally, which was the red one. So Desmos makes things very user-friendly for students. So things that I love about Desmos is you can easily double-click to zoom in. You can also click on intersection points, so to find intercepts and so on. Or if you had another function in here, like maybe I wanted to find where the circle intersected with the basic parent function for a parabola, I could find those points. So it's very user-friendly for our students, and hopefully it will be user-friendly for you as well. Other shortcuts, so I showed you that you could do SQRT to get a square root. You can also do CBRT to get a cube root. You can also go to the keyboard, which has all of those different functions there. If you go to functions, we have trig, stats, dist, mix, misc. And so you can find those different things as well. We'll be talking a lot more about stats and distributions on Friday. So if I minimize that keyboard again, I can try some different shortcuts. If I put in pi, that puts in pi. If I put in theta, it puts in a theta for me. And I can spell out the word infinity to get infinity as well. So lots and lots of shortcuts. All right, so as for graphing points. So graphing points is super simple. All we do is we put it in just like a point. So if I wanted to graph the point at 2, 4, I would put that in, and then I can label it whatever I want. So I could label it with point A, or I could say, this is where Jenny's house is located, and write out something like Jenny's house. As I told you, scrolling, zooming, and changing windows is really easy. Scrolling and zooming, I can, pull the screen much like students pull on their phone. There are Desmos apps for the phone as well. So I can pull it up and down. I can also zoom in and zoom out with the plus buttons. And also changing the windows is super simple as well. So if I go to Graphs Settings, I can change my axis to whatever I want it to be. So if I wanted it to be negative 100 to 100, I could do that. Notice how it's kind of distorting my graph though. I could do zoom square and it puts it so it's kind of the same on both the X and Y axis. And then again, I could zoom in and so on from there. The thing that I like about changing my windows is sometimes I don't like the steps that are given. So you can see that this is doing 0, -5, -10, -15, and so on. But on some graphs, for instance, y equals sine of x, maybe I don't want it to be every 5. I instead want every pi, or every pi over 4. So let me get rid of some of these. So if I want these labels to show up in radians, what I can do is I can go to my settings. It's already selected with radians. Degrees would be a little different, right? And I can select the axis to be from maybe -2 pi. So again, I'm putting in pi to 2 pi. And then I want my step to be every pi over 6. So I do pi over 6. Oops, did I do 2? And so I can put that in. Maybe I did 2. Let me zoom in a little bit. There we go. I just needed to zoom in a little bit to get the pi over 6. So then I can see those different measurements. And again, I can drag. And then the nice thing about Desmos is I can see those intercepts, and I can also see max and min values. So it's kind of a game changer for students because it's very, very easy. It's much easier than a graphing calculator where you have to do second trace, select maximum, left bound, right bound, guess, right? So it makes it a lot easier. And it's also really powerful when you're trying to determine, basic transformations. So let's say I wanted my settings to only go to -3 to 3. Oops, not -37. -3 to 3. And I wanted to see what happened to sine of x as I put a 4 in front. Well, I can see that that's a vertical stretch of 4. And I can see that my maximums, instead of being at a height of 1, they're now up here at a height of 4. Okay, or maybe I wanted to see what happens when I put sine of 2x. Well, that ends up being a horizontal compression by 1/2. And I can see that that adjusts what I call the period. So if I don't want to see this blue graph, I can just click on it. And I can say, well, previously my red graph went from 0 to pi to 2 pi, and that created one period. Well, this is now going from 0 to pi for one full period, and 2 pi gives us 2 full periods. So I've now adjusted the period by halving it. So very powerful things that you can see with Desmos. Okay, so you don't just graph equations. Sometimes you want to graph inequalities as well. So if I'm graphing an inequality, let's say I want y is less than 3x plus 2. Okay, so I have that. It graphs the half plane. And I can change those colors just like I changed the color of lines. I can go to settings, which was, did you all see the little cog thing? And then the purple, I can select it to be yellow or green or black, whatever we want it to be. So let's say I have that. And then what if the next one I wanted less than or equal to? Well, then I just do my y again, and I can either hold down oops, I messed it up. Alt or option, and then do it that way, or I can put it in as 2 pieces. So I can say less than, and then I can hit the equal button after it. So if I hit the less than and then the equal, it puts in less than or equal to. Or I could do, like I was saying, just holding down Alt and holding down less than, and it does it in one. So let's say I wanted -2x plus 5, and I don't want that to be black. Then I go to my cog again, and I change it to maybe red. And I can see that intersection area. And then if I wanted corner points, for instance, then I just click on where I think it's matching up, and I can see that it's 0.6 and 3.8. Okay, so that's how we graph our equations, our inequalities, and notice how we were graphing things that were not just functions. We graphed x squared plus y squared equals 25. Well, we could also have things like hyperbolas or parabolas, or even, crazy things where we have like things like that. So it's not just limited to functions when you use Desmos. Okay, so let's talk about piecewise functions. So piecewise functions often has a really fun activity that you can do with Desmos. So you should look up some of the Desmos drawing pictures by Googling. You can just put in Desmos drawings. A lot of teachers have their students spell out their names. And I think that's a great activity with this piecewise function. Okay, so for instance, let's say I wanted y equals x squared. And again, I could just put in x squared if I want to. I don't have to do the y equals. But I didn't want to see the whole curve. I instead wanted to see only from, let's say, this area to here. So I'm going to say between like -1 to 2. Then I use my brace, which is where the bracket button is. And I do -1 is less than x, which is less than 2. And I put that restricted domain in. Okay, so now I can see that I have just part of that parabola. So maybe this is the j part for my Jenny. And maybe I wanted to cap it. And so I wanted to put y equals 4. And I wanted that only from 0 to, I still have it in terms of pi, don't I? So let's say 0 to 3. So I can't put it in like that. I have to do my less than x, which is less than 3. And I end it, and it puts this little hat on my j. So if I wanted it to be the same color, I can go to settings and put that as the same. You can even do like dotted lines and so on, or dots if you want as well. And then I could finish off the rest of my name. So the cool thing with Desmos is there are students that do some really complicated drawings with this, and they even involve some shading and so on. So it's really cool to look at. You should definitely Google some of those images. Actually, I'll pull up the, oops. So here's the PDF that I'm looking at right now. Oops. And here's a couple examples that I have. So these were found on arithmetalk.com. So someone spelled out the word volleyball and then did a cute little volleyball, and someone did a little chick. So that would be a fun activity for your students to do. All right, so moving on. So sliders and animations. So sliders, in my opinion, are some of the most powerful tools on Desmos that really help with students' conceptual understanding. So if I look at my normal y equals mx plus b, when I put that in, I have letters other than my x and my y. So it's telling me, like, do you want to add a slider? And so I just hit all. It's going to give me a slider for m and for b. And when you do this, students can see what's happening with the slope. So as you slide up and down, notice how when you cross 0, you now have a negative slope. And then they can see, oh, well, what if I keep this at, 1.3, but I move this one? Well, it's moving it up and down this axis when it does that. So they can kind of play around with sliders, and it's really cool to see what happens to graphs. So let's say we take our parent function, y equals x squared, and we want to put a slider in. Then we do a, and we can see what happens as we increase a. So as a gets big, it actually looks skinnier, right? What's happening is we're stretching the y values out. And then as we go this way, as a gets negative, it flips upside down. There's a reflection that's happening, and again, it's getting skinnier. And you can make these as big as you want. So you can make it go to 100 and -100. And then maybe you go by every 10, and you can animate it. So you can still do your little clicking away, and it's doing just kind of a choppy every 10. Or you can animate it and just let it go ahead and play by hitting this play button. So notice I hit this. This one means it goes forwards and back, and these other ones just go forwards. So if I hit play, I can see it getting bigger and smaller as a gets adjusted. Okay, so I like sliders sometimes when we have maybe systems of equations and we're trying to figure out what variables, like what coefficients on x and y are going to make two equations parallel or something. I also use it with a projectile motion project that I do with my students, where they're trying to find the initial velocity and the launch angle. All right, so the next thing we have is converting to a table. So Desmos allows you, just like a graphing calculator, to see table values as well. So if you remember when you would put in something like y equals sine of x into your graphing calculator, you could do second table, and it would take you to a table of values, and you could input different things. So you can do that on Desmos as well. You just go to your edit list, the little cog, and this function right here that says convert to table. So we can see that we have these different values. So if I wanted to put in numbers that make a little bit more sense for pi, maybe I do pi over 6, I get 1/2, or pi over 2, I get 1, or pi over 4, well, I did 3, but 4, and so on. I get those different values, and I can click on them and see them as well. All right, and then the last things I want to talk about are some kind of math past the basic Algebra 2, I would say probably pre-calc and beyond, which are things like polar coordinates, parametric equations, derivatives, integrals, and so on. So let's look at polar coordinates. So polar coordinates are so fun to do on Desmos because students can immediately edit their graph and see the crazy things that are happening to it. I'm going to delete this table. And so if you remember with polar coordinates, it's always starting out with r equals something with theta. So let's say I do 4 sine of 5, and I write out theta, T-H-E-T-A, and it puts a theta in. Okay, so this is one of the rose curves, and it has 5 petals, and students could play around with this, and they could say, well, what if I put in a 3? Oh, I have 3. What if I put in a 4? I have 8. What if I put in a 6? I have 12, and they can start to see that there's a certain pattern with this. Now, polar coordinates we know is on a polar grid, which is not this Cartesian coordinate plane. So I can go to my graph settings, and I can go to my grid or my polar coordinate graph here. And then the x and y axis, that's not really where we're editing a polar coordinate. We're editing it here. We're saying from 0 to like 2 pi usually, or you could do more. Like sometimes people want to do r equals theta, which is the spiral. But if you only do 2 pi, you're only seeing part of that spiral. So it's nice in that instance to go even bigger. And you can see lots and lots of those spirals. So that's our polar coordinate grid. And then we can also do parametric equations. So let's say I go back to my normal Cartesian coordinate plane. I'm going to make my step just -1 and 1. And I'll do just the normal 10 to -10. Okay, and I'm going to clear these out, and we're going to talk about parametric equations. Now, parametric equations, I know you may not teach them in your courses right now, for instance, if you're teaching Algebra 2 or below, but they are useful when you get to Activity Builder. So with Desmos, there's desmos.com Activity Builder, and this allows you to create like informal assessments or formal assessments for your students, and just these e-learning opportunities. So if you have e-learning days, you can have students work on a Desmos activity and so on. So parametric equations, the nice thing about it in Activity Builder is it makes your graph not clickable. So for instance, if I put in y equals x squared, okay, students can click on any location and they can drag that point around and they can see points that are along there. Okay, so if you're trying to create an activity and you don't want students to be able to click it to find out different points, like maybe you're having them fill in a table of values or something, you don't want them to be able to click on those different points. Okay, so what we can do is we can put it in as a parametric equation. So we do t comma t squared, and we just want our values, see how it's only from 0 to 1, so it's plugging in all these different tick marks from 0 to 1. So I'm going to do -100 to 100. So if I zoom out far enough, I'm not going to see like it continuing on and on and on, but this at least makes it pretty big for the students. So we have that. And so in Activity Builder, you can do something where you hide the folder. So you put this parametric equation in, and if you notice, see I still have that one selected, it's no longer clickable. So I can't click on any part of this and see any point, like my intersection points, or intercepts, I guess, and maxes and mins. Okay, so that's important in Activity Builder, and it's also just kind of cool to be able to graph parametric equations. So a typical parametric equation might be t -4.9 t squared plus some kind of initial velocity times time, well, sine theta times time, and then plus an initial height. So if I put something like that in and I go from 0 to 10, what it does is it shows me, like if I launch this projectile into the air, it shows me that it goes up to this highest point and then back down, and it crosses after around 3.5 seconds. Okay, so I can see that with parametric equations, and it's pretty easy to put in. Okay, so let's see. So the last things I wanted to show you were derivatives and integrals. So derivatives and integrals are pretty easy to input. If I wanted to do the derivative of x cubed, many of you guys probably know the derivative of x cubed is 3x squared, right? So it's graphing 3x squared. So I can check by doing 3x squared and it's right on top of it. Okay, or if I wanted to check the derivative of sine of x, this is one that, you know, calc students always forget, like what's the derivative of sine? Is it cosine or is there negative cosine? Then I can see the derivative of sine of x, oh yeah, it's definitely cosine of x, right? If I did negative cosine of x, it would be off. Okay, with integration, you can put in int, and it gives you a definite integral. So I do -2 to 2. And maybe I want square root of 4 minus x squared. So this is like the area under the top part of the semicircle with a radius of 2. And I put in my dx, and it gives me that answer right there. So the tricky part is it doesn't actually give you the drawing. So you could always, put in square root of 4 minus x squared. And you can think, oh yeah, this is the area under this curve. I'm going to make it more square. Zoom square. So we can see that that's half of a semicircle. And basically it would be this part that's shaded underneath. So as for the shading, I think you can do, yeah, so I wondered if it would, you got to do something like this if you want to see the shaded portion. And I do have that on the handout as well. I have kind of a little activity that, not activity, but I found some coding from a pre-made activity. And I'll show you how complicated it looks. It looks like this. So it allows you to use sliders to see as your area goes from A to B. And as you slide these, it's going to shade different areas that are represented. But putting that area in is a little tricky. So see how we have f of x is greater than 0, and then f of x is less than 0. So it's a little complicated. You can always copy that code over if you want to. In general, my recommendation for you guys as you're working on e-learning is to don't try to reinvent the wheel. Like, it's great that you get these basics to Desmos, and you can always reach out and ask additional questions if you have them. But don't try to go into Activity Builder and think that, oh, it's going to be really easy. I'm just going to create this lesson. Because sometimes it's challenging at first, especially Activity Builder. There is some coding that's involved that makes it a little tricky. So what I recommend is that you use a pre-made lesson. So if you go into Google and you put in Desmos quadratic functions, let's say, you can see that there are collections, Activity Builder custom, and so on. Usually when it says custom, that's something that someone else has created and you can use. So if you go in here, you can see that this was made by Kelsey Marquette. Thank you, Kelsey. And you can go to copy and edit, and you can copy that, and then if there's certain screens that you like and you want to keep, you keep them. But if there are certain things that you don't like, so you can go into the student preview, and you can try these different questions. But if there's ones that you don't like, then you just get rid of them, so you can delete them. So just make sure you copy those over, and you can edit from there. Like I said, don't reinvent the wheel. Like, you can use others' creations. Or if you really like Kelsey's graphing quadratics, then you can do create class code and sign into your Desmos page, and you'll give your students that code. Okay, so when they go to Desmos, they will go to student.desmos.com, and they'll enter the class code, and you'll be able to track their work. So I'm definitely going to show that in my next couple webinars, so you can see more at that point how to track student work and how to give them feedback, not necessarily through Desmos, but you can screen capture They have a little button that allows you to take a picture of student work and share with the whole class and say, hey, I really liked Joey's ideas here, and Desiree had some good ideas on number 2. And that way you're still interacting with your students even if you're in e-learning. All right, so that is all I have for today. There are lots of activities already on Desmos, so you could go to teacher.desmos.com, and you can see the pre-made activities made by Desmos Fellows. Those are great activities to use. They have been tested and really perfected. Or you can go to Google and you can try to find other activities there as well. There's also a link through learn.desmos.com that has some videos from Desmos creators, and they give you some pointers on how to create some good activities. All right, that's all I have for you today. Good luck.